Hi, my name is Johannes and I'm Chief Technology Officer at TECHNIA. I am responsible for our products and technology and have some 25 years of experience from digital transformation across a wide variety of industries. In this session, I will talk about our approach to digital engineering and explain how product lifecycle management and virtual twin technologies is fundamentally changing the way engineers work together when developing new products. But first, a few words about TECHNIA and what we do. We provide tools and methodologies to help our customers develop more sustainable and better performing products. In doing that, we help our customers work efficiently across all phases of the lifecycle of the product and to optimize collaboration internally as well as with partners. In short, we help making product creation sustainable. So, what is a life cycle? We know from nature that all living beings have a life cycle that spans from conception to death, before it all starts all over again with a new generation. It is very much the same for products. The product life cycle includes phases like innovation, design, simulation, manufacturing, maintenance, and repurposing, before the next generation of the product emerges as an improved version of the previous one. This process is known in the industry as product lifecycle management. The product lifecycle starts with what we call the virtual lifecycle. This is the product development phase, where the product evolves from idea into a final design. The innovation phase is about collecting ideas and describe the requirements. In the design phase, these ideas become technical solutions that form the basis of the product's detailed design. As the amount of information expands, more formal processes are needed to stay in control. Before entering manufacturing, the product undergoes simulations to verify that it meets the initial requirements. The physical life cycle of the product starts with manufacturing, where digital models of the factory is used to plan and optimize how the product is produced and how it is assembled. The models that have been created during the design phase can also be reused to support marketing activities in visualizing the product to create catalogs and marketing materials. During operation of the product, the digital models from engineering and manufacturing helps optimizing maintenance activities, including the provisioning of the correct spare parts. When approaching the end of the life cycle, the digital model is key to efficient repurposing and recycling of the product by providing insights to all materials and all activities used to build and to operate the product. To illustrate what this means in practical terms, I would like to share an example from our customer, Kongsberg Defence and Aerospace. Every summer, a group of engineering students are given the task of designing and developing an autonomous drone called the Local Hawk. While this is a quite simple product, it still requires the collaboration of several engineering disciplines, including mechanical, electrical, software, and aerodynamics. In a traditional way of working, a multitude of software tools would be required, as well as the creation of a huge number of documents to fully describe all aspects of the drone. Switching to a model-based way of working and establishing a virtual twin of the product, the documentation effort could be greatly reduced and the design iterations can be performed much faster than before. When working model-based, the model, or rather models, are the main carriers of information. The mechanical design is captured as a 3D model. The structural strength is verified using a finite element model, and the behavior of the system is described as a system model. The system model contains requirements, use cases, state diagrams, logical building blocks, test cases, and more. Tying all these elements together puts you in full control of all important aspects of a product to much better predict how it will perform in real life. After the product is put into operation, the system model provides full traceability to quickly find the root cause in case of failure during operation. The virtual twin is at the heart of digital engineering. It can best be described as a lifelike digital model of a product or system, which help engineers explore the solution space and analyze how the product will behave and perform in real life before a single prototype is made. To exemplify, it will help answer some of the key questions engineers need to find the answer to, like, what are the requirements? How should it work? Will it break? How can we assemble it most efficiently? What should it look like? What is the environmental impact? These and many more questions can be answered much more efficiently when you apply virtual twin methodologies made possible by state-of-the-art innovation platforms like 3D Experience, which helps optimizing the flow of information between all actors in the product lifecycle. We call this digital continuity. There are 3 things I would like you to remember after this presentation. Firstly, at TECHNIA, we help our customers create virtual twins to develop better performing and more sustainable products. Secondly, digital engineering and model-based methodologies allow you to focus on optimizing the product rather than creating documentation. And finally, our key contribution is the combination of 3D Experience, TECHNIA software, and expert consultancy. Feel free to reach out or visit technia.com if you want to learn more about how we can help you digitalize your product development process. Thanks for listening.